Hey, Science 20s, a little bit tougher problems now. We are going to be going from moles to mass. Now, this is going to require a periodic table and a calculator because as soon as we start talking about mass in chemistry, a variable that almost always goes with that is molar mass. So in the Google Classroom, if you missed it in the notes, there is the periodic table and your data booklet. It's there for you to use. Okay. So this question is the same one that was in the previous video, but if we look at it, it's a little bit different. It's saying how much mass of silver is made from 8.2 moles of zinc. So same thing, check if it's balanced. It's balanced. Write down what we know. 8.2 mole of zinc, and we don't know mass. And the unit for mass is grams, or G. Another variable that's going to always go with mass when we do these problems is molar mass. So we need to write down the molar mass of silver. Now in this video, I'm going to give it to you. But when you actually have to do the worksheet, you're going to have to look it up for yourself. So the molar mass of silver is 107.87 grams per mole. The 2 in front, this 2, that doesn't affect the molar mass. But when we do a little bit tougher problems in a second, numbers after that will affect the molar mass. Okay. So we're down to, there's basically 3 steps to solve these problems. And I'm going to go through those 3 steps every single time. The first step is write down what you know. Okay, so we know all of this. We've wrote down what we know. We've got the molar masses. The second step is we have to take the moles of the substance that we know and change it into the moles of the substance of what we're trying to solve for. That second step is called solve moles of required. So that strategy that we used in the last question, we're going to use that same strategy here. The question mark, the thing that we don't know is grams. So we have to turn the moles of this substance into the moles of that substance. And to do that, we have to use that ratio, required over given. Okay, so we're going to do that really quick. 8.2 mole times 2 over 1. And how am I getting 2 over 1? Quick recap. Where are we going? The 2. Where did we come from? Zinc. There's no coefficient there, so it's 1. So we're timesing that by 2 over 1. We get 16.4 mole. Okay. Now that tells me how many moles of the silver we have. That's the second step. The third step is to use the mole formula and solve for mass. Okay, that formula is in your data booklet. So there's a lot of new information I'm throwing at you right now. We're going to practice this a couple times. The molar mass formula looks like this. Number of moles, N, is equal to little m over big M. And little m is mass, big M is molar mass, and little n is moles. We need to rearrange this for the mass. So what I'm going to do is times both sides by the molar mass. That cancels, and what I do to one side, I have to do to the other. So my formula is mass is equal to number of moles times molar mass. And guess what? Because of my planning, I have both of those ready to go. 16.4 mole times 107.87 grams per mole. Okay, so I'm going to times that out and see what I get. Oh, my 1 kind of disappeared there. 107.87. 16.4 times 107.87. I get a really big number. I get 1769 grams. Now, proper sig figs, if we're going to do that, and I'll do that, is 2 sig figs. So round this to 2 sig figs is 1.8 kilograms. There are 1,000 grams in every kilogram, 1.8 kilograms. If you left it like this, that's probably okay for the Science 20 level, but we should always be attempting to round to the correct digits. We're going to get to physics soon, and every time you're going to be needing to round properly. Another way we could do this in proper sig figs is 1.8, because we can only keep 2, and we move the decimal back 1, 2, 3 times 10 to the 3 grams. That's another way to round that to 2 sig figs. Okay, let's move on to the next problem, mole to mass. This one says, how much mass of ammonia is made from 4.2 moles of hydrogen? Okay, so the first step is write down what you know. Okay, perfect. So we have 4.2 moles of hydrogen, and it's asking us to solve for mass of ammonia. From the previous question, what goes with mass? Molar mass. Now, ammonia is built out of, if we look at it, it has 1 nitrogen and 3 hydrogens. Again, that coefficient doesn't impact the molar mass. We don't need to worry about timesing that by 2. So the molar mass for ammonia is nitrogen is 1401, and every hydrogen is 101, but I have to times that by 3. So when I add that up, I get 1704 grams per mole. That's the molar mass of ammonia. 1 nitrogen, 3 hydrogens. 1704 grams per mole. Okay, so that's the first step. The second step is use mole ratio and find moles of required. Okay, so where are we going? Where have we been? This is where we're going. We're going to find the question mark that way. So I'm going to have 4.2 mole, and I'm going to times that by the ratio of 2/3. Because this is my required, I'm required to solve it, and that is my given. 4.2 times 2 divided by 3 gets me, just like the last problem, 2.8 moles. And that leads us to the third statement. Use the mole formula to solve mass. Okay, so the mole formula, just like on the previous page, N is equal to little m over big M. Little n is moles, little m is mass, big M is molar mass. So we have to isolate the little m. I'm going to times both sides by big M. What you do to one side, you do to the other. So mass is equal to number of moles times molar mass. And because of my planning, I'm good to go on this. So if I check back up here, that's my number of moles. That's my molar mass. So 2.8 mole times 1704 grams per mole. Okay, so when I type that into my calculator, I get 47.712. Now, if I go back up to the question, how many digits do I round it to? 2 digits. This one's going to be easy. So I round this to 47 grams. Okay, so there's a couple problems. The good thing about the video, guys, is you can always go back through and use the video to solve for the things that you're going to be working on today. Tomorrow, so that is, I believe, Wednesday, you're going to be doing some worksheets on this stuff. So it's good that you looked at it today. You might have to look at it again tomorrow. All right. Have a good one.